All right. Morning, everybody. We're going to go ahead and get started and continue on with what we did last week. Last time we started in CR 15. This was talking about the imaginary numbers. So we're just going to go ahead and continue that. We'll be able to finish this section today, and then we'll go on to section 3.3, which is kind of what all this these two sections are kind of building up to of what we'll do in there. So we left off talking about how we write things in what's called standard form. You have the real number part and you have the imaginary part that comes after it. So we're going to continue and we're going to do some operations now with imaginary numbers. And that's what we'll do next with these. So we're going to talk about adding, subtracting, multiplying, and dividing imaginary numbers. So first we'll go ahead and do addition. Now when you add this together here, you're adding the like terms together. So all you have to do is add the numbers and add the i's together. Much the same as you would do if this was x's, you would do the same thing. So we got 14 right there from 9 and 5. You have a 12 minus 2, and that's plus 10i. And then that's it. That's all you would do for that one. Just add the like terms together. So kind of group the, if you wanted to see if there was any work to show for this, you can say that I did this. I just went ahead and I rearranged put the like terms together. So we got the number terms and the I terms together. I put an I right here. And so that's what I did for that one. And that's all you have to do. So combine it together to get this. Now you don't want to factor this because if you want a standard form, you don't want to do that. You actually just want to leave it with the A and then the BI like that. Okay, next we've got a minus sign. So the first thing we want to do here is to distribute the minus sign. So minus sign into here, negative, negative will give you a plus 2. And you have a minus and a 6i. So you have minus 6i right there. So that's the first step, is to go ahead and distribute the minus sign through. From there, we're going to do the same thing we did for the previous one. We're going to add the like terms together. So we're going to take our 8 and 2 and make that 10. Negative 5i minus 6i is minus 11i. And that's it. That's going to be our answer. And so 10 minus 11i we would put. We got another one of these, a you try it problem. So we'll just go ahead and do this one as well. So we again, with these, you want to distribute the minus sign. So we have 3 minus 2i, and then we have minus 5. And then this is going to be a plus here because you have a minus and a minus. Okay, so we have plus 7i. So it switches both those signs. Then we have 3 minus 5. That's going to be negative 2. You have negative 2i plus 7i, and that's going to give you a plus 5i. So a question that comes up with this problem is, can I write my answer as 5i minus 2? And the answer is no, because if it says write the answer in standard form, that means it has to be, the real number part has to come first. So we have to do negative 2 and then plus bi. So it has to be written specifically that way in order for it to be correct standard form. All right, so now we're going to go on to multiplication. And now you multiply these the same you would do if there's x's. We're actually going to be using the foiling method. So we do we're going to start with the first term times each one of these. We're going to begin by doing that. So we're going to take 2 times 3 is going to be 6. And we have 2 times negative 4 is negative 8i. Now we want to do the inner terms. So we're going to do 5i times 3 is plus 15i. And then we're going to take 5i times negative 4. 5i times negative 4, we get negative 20. But remember, this is going to be I squared because there's 2 i's we're multiplying together. So the next thing we want to do is add the like terms together. Negative 8i plus 15 is a 7i. Now, we talked about this last week. We said that I squared in that chart that we started with, we said that I squared is equal to -1. That's one of the things that we had on our chart, one of the first problems that we talked about. So anywhere you see I squared that comes up, whenever you're doing multiplication, division, any of those operations, you want to always replace the I squared with -1. So we're going to do that next. We have a -20. Instead of I squared, going to replace it with -1 because that's a kind of an identity or a definition. From here, we're just going to simplify it. So we're going to get a +20 from that. And then we're going to add like terms together, 26 plus 7i. And then that's going to be your answer written in standard form. The real number part comes first, 26 comes first, and we have the b part that comes second. Let's do another one of those multiplication ones right here. So we've got 1 times 5. We'll do first. That's going to be 5. Then we have 1 times -9i. So we're going to get -9i there. Let's multiply these. 2i times 5 is going to be plus 10i. And then we've got 2i times -9i. That's going to be negative 18. And then we have the I squared. So again, we just do the FOILing process on that. 1 times the 5, 1 times -9. Then we do 2i times 5, and then 2i times -9i. So now we have this. Add these together. That's going to be 10i minus 9. So we get 5 just plus I. So 1i left over here, 10 minus 9. We have minus 18. Once again, anytime you see I squared, you want to put in -1. So put -1 in there, we get 5 plus I plus 18 there, and then we can add that together to get 23 plus I is going to be your answer for this one. Okay, the next problems we're going to go to are going to be the division problems. Okay, so we've got here's the next example, we have division. Now, if you're doing division, the way that you want to always do these kind of problems is you want to multiply the whole thing by the conjugate of the bottom. We want to make this bottom go away to where there's no I there. So although it looks like it's in standard form, each individual numerator and denominator, those are both in standard form, but the whole thing is not. So the idea is we need to get rid of the I from the denominator. The way that we're going to do this is we're going to multiply the top and bottom by the conjugate of the bottom. What I mean by conjugate is the same thing you see there, except it's going to have an opposite sign. So it's 3 plus I, the conjugate would be 3 minus I. If we had 3 minus I on the bottom here, we'd be multiplying this by 3 plus I. You're always going to multiply by the opposite sign. Now, the reason why we're doing opposite signs is because when we multiply these, what's going to happen is you'll get middle terms to cancel out because we'll end up doing a difference of squares. So you'll see, let's go ahead and do that right now, actually. Let's multiply the bottom so you can kind of see what happens there. So 3 times 3 is 9. 3 times -I is -3i. Then you've got these terms. 3 times I is plus 3i there. And then you have plus I minus I, that's going to be minus I squared. So what you're going to see happen here, and I'll just go ahead and simplify this all the way out. Then we'll do the top and you can see what happens there. But these two things, those cancel. And then instead of I squared, we're putting in -1. Okay, so we got that right there. And so now, as you see here, this is going to turn into a 10 on the bottom. So that's actually why we're multiplying by a conjugate, because in doing so, and it only works, by the way, if you have opposite signs. If you multiply by the same sign, you're not going to get the middle terms to cancel out. So the idea is you don't want to have any more i's in the denominator. And this is actually why we're doing the conjugate, because you get the difference of squares, terms cancel, and you get a number left over. But now that we're done with this, let's go ahead and multiply the top one. So 4 times 3 is 12. 4 times -i is -4i. Now we're going to do -2i times 3, -6i. -2i times -i is plus 2i squared. Now we're going to simplify the top. So 12, we have minus 10i from these terms here. We have a 2, and then the I squared, once again, we're going to put a -1 in there for that also. Now we're going to keep on going, and we want to simplify what we have. So this, you're going to get, this is 12, and then we have minus 2 here. So we're going to get a 10. So 10 minus 10i. On the bottom, we did that already, and we're going to get a 10 down here. So we can take now and divide everything on top by the bottom. So we're going to split this up and make it two separate things. You want to take it down to this step, because if you leave it in this fraction form here, this is not in standard form, because we've got a fraction still. So that's why you want to take it over to this. And sometimes this reduces and sometimes it doesn't. In this case, it does in fact reduce, and you're going to get 1 minus I as your answer, and that would be the final answer in standard form. So by dividing all this, we end up with 1 minus I, and that would be your answer there. This problem is combining something we talked about last time and also what we just talked about with dividing. Now, before you jump into and do the division on this, we have to first turn all this into the standard form. So we want to get rid of all these radicals that we see here. Square root of 4, this becomes 2. So that's easy enough. Now for the square root of 49, that is the same thing as 49 times -1, which means that's the same thing as square root of 49 times 49, if I can write here. 49 times square root of -1. So this is actually going to turn into a plus 7i. Square root of 49 is 7. Square root of -1 is I. Okay. Now the bottom one here, square root of 25, we can do that right away and get 5. We have a minus sign. This square root of 9 here, you can write that as square root of 9 times square root of -1. So we get a 3i as a result there when we break that up. Now we have it written out in proper form. So next we're going to go ahead and go directly into the process for dividing it, which means that you want to multiply the top and bottom by the conjugate of the bottom. By the way, we're only doing the bottom because that's the part where the I has to go away from. Okay, so we're always focusing on the bottom, the denominator. We want to find the conjugate of the denominator. So if it's a minus, then it's going to be a plus. Okay, so now we're going to multiply this. Let's do the top first. 2 times 5 is 10. 2 times 3i is 6i. Now we're going to do 7i times 5. So that's plus 35i. And then we're going to do 7i times the 3i. We get 21i squared. Okay. Now we'll do the bottom. 5 times 5, 25. 5 times 3i is 15i. Negative 3i times 5 is minus 15i. And negative 3i and positive 3i, that's going to give you negative 9. And then that's going to be I squared. In the next step, we're going to simplify the like terms, and we're also going to put a negative 1 in for the I squared. This is 10 plus 41i from this, and plus 21 times negative 1. Now down here, we have the 25 is there, but the 15 i's, those are both going to cancel out. So we can just write 9 and then times negative 1. Middle terms cancel out, and then we put a negative 1 in for the I squared there. Going to continue with this. We have 10, and that's going to be minus 21. So 10 minus 21 is negative 11 plus 41i. 41i, and then down below, this is 25 plus 9, so we're going to get a 34 down below there. Now we're not done yet because this is not proper standard form, because you have a whole thing divided by 34. So in order to make it standard form, we have to go one more step, and we have to break this down further. So negative 11 over 34 plus 41 over 34i. Just going to leave it like that as a fraction. There's nothing more we can do as far as simplifying on this, and that would be considered standard form. So that's as far as we can go. So not always will these reduce. Sometimes you might end up with a fraction like this that can't reduce, and that's fine. You can just leave your answer in that form. Let's do another one of those type. Let's do this here. All right, so this one, we're going to, again, change this into standard form. Square root of 9 is 3. Now, here's a shortcut that you can do for this. If you ignore the negative sign there, we would get a 4. And then because there's a negative, you can just go ahead and stick an I in the end. So that would be the shortcut way of doing it. Okay, so you don't have to worry about the showing the steps on it. So again, what I did there was I did square root of 16 times square root of negative 1. You can break that up like that, and that's how I got a 4i. Down below, square root of 64 is 8. And then square root of 4 would be a 2, and because there's a negative inside the square root, that means there'll be an I that comes out there. So this problem, if you change it into turns into this. Then you're multiplying by the conjugate of the bottom always. So you're multiplying it by 8 plus 2i over 8 plus 2i. It's the opposite sign of what you see down below here. We'll multiply that now. 3 times 8, 24. 3 times 2i is plus 6i. 4i times 8 is plus 32i. 4i times 2i is 8i squared. Okay. So foiling that in the bottom, 8 times 8, 64. 8 times 2i is plus 16i. Negative 2i times 8 is negative 16i. Negative 2i times 2i is going to be negative 4i squared. Next, we're going to add the like terms and put a negative 1 in for the I squared. 24. 6 plus 32, 38. So we get plus 38i. And then plus 8. And then instead of the I squared, we're going to put negative 1 in there. On the bottom, we get the 16 i's are going to cancel out. So we get 64 minus 4 times negative 1. Again, we put I squared in for the I squared. We put negative 1 in for the I squared. Simplify this. 24. Now we have 24 minus 8. Okay, so we get 16 plus 38i. And then we have 64, that's going to be plus 4, so we get a 68 that's here. Then we just need to divide both of these by 38. 68, not 38. 68 here and 68 here. Okay, so we divide both of them by 68, and we have an I that we have here. Now this can be reduced. So on each of these, you can try starting out by a 2 and doing that. We know they're both even, so we can definitely divide by that. But also we can try a 4, and 4 would be the better one here. So we're going to try the biggest number that divides evenly. So 4 goes into both of these, and so 68 divided by 4 is going to give you 17. This one here, 38, 38 is not divisible by 4, but it is divisible by 2. So we can divide the top one by 2, and we're going to get a 19. Divide the bottom one by 2, and we get a 34. Okay, so we get 19 over 34, and then that's it. You just reduce them as far as you can go. They don't reduce anymore, so you just leave your answer like that, and that would be the final answer. All right, now the whole reason why we're simplifying and working with standard form is because of some problems here that involve the quadratic formula. Now, we did the quadratic formula last week in the section right before this one, but now we're going to combine this together with imaginary numbers. So these two problems are ones where you're not going to get a real number solution, you're going to get an answer with an I in it. So we're going to go through and do quadratic formula again, and then we're going to most likely we'll have our answer in standard form. Okay, so here's the A is 3, the B is -4, and the C would be 6. Recall from the last section, I'll put the formula up here again for here is the quadratic formula from the last section, and we're going to use that here. We'll just plug in our A, B, and C. We want to simplify this as far as we can go. Be careful with the B here, because B is negative, so we have a negative times -4, plus or minus square root. We have -4, that's B squared. 4 times AC, the A is 3, and the C is 6. All that over 2 times A, or 2 times 3. So now we put everything all in there, all the A's, B's, and C's. We want to keep going with this. We want to simplify down as much as possible. Negative times -4 is +4. 4 plus or minus the square root. Okay, so inside here we've got 16, and then we have minus. Right here we've got a 12 times 6 is going to be 72. All over 6, 2 times 3. Now we want to keep on going there and simplify. We already see that we're going to have a negative number inside the square root. We have 16 minus 72. So let's subtract that. If you subtract it, you're going to get -56 inside. Okay, so now 56, we can divide that by 4. And so this is 4 plus or minus. That's going to be, we can do 4 times 14 times -1 inside there, which means that we can pull a 2 outside of here, and an I we can pull out as well. So we get 4 plus or minus, that's a 2i square root of 14. Again, remember, if you have an I and a square root, it's better to put that on the outside of the square root, so that way we know for sure the I belongs outside there. 14 doesn't break up anymore because that's 2 times 7, so no, that doesn't do any more there. There's a 6 in the bottom. We'll go ahead and divide each of these by 6 at the same time. I'll distribute, or just divide each of those by 6 to break up the fraction. And then finally, I get 2/3 plus or minus, this is I square root of 14 over 3 we get for that. And you want to keep it, even though we have common denominators, you definitely want to keep them as two separate things if it asks for standard form. So 2/3 would be the A part, and then you've got the plus or minus the I root 14 over 3. So that would be your answer there. Okay, this is the last problem in this section, then we'll go on to 3.3. Again, we've got the A, B, and C on this. So we're going to go back up to the same quadratic formula. I won't rewrite it since we got it up here. And I'll just jump right into plugging in the A, B, and C. So I have another negative and a negative B. So I have negative times negative 12 plus or minus B squared, negative 12 squared minus 4 times AC, 4 times 4 times 13. Okay, just like that, all over 2 times A, 2 times 4. Okay, so that would be A, B, and C put in there. Next thing we want to do is just try and simplify that as much as possible. Okay, so I have x is equal to 4 plus or minus. Okay, so inside here, negative 12 squared is 144. And then inside there, I have 208. 4 times 4, 16 times 13 essentially is 208. All that divided by 8. Okay, so now we're going to do that. Inside, again, we see another one where we're going to get an imaginary number as an answer because you end up with a negative number underneath. So exactly, you get negative 64 inside here. Okay, negative 64 all over 8. This is actually one now. We won't end up with a square root left anymore because that goes in. It's a negative square root of negative 64. Square root of 64 is 8. So that's going to give us an 8i. And then we have this divided by 8. And so then what you want to do is break this up and divide both of these by 8. So 4 over 8 is a half. And then plus or minus 8 over 8 reduces to just plus I. So you get 1/2 plus or minus I, and then that would be your answer for that one. All right, so then that would be it. So this is it for CR 15. So again, the CR 14 and 15, those are review sections, basically to give you some foundation to do the 3.3 section, which we're going to talk about quadratics. So the whole point of doing all this and working with imaginary numbers and everything is because we might get some imaginary answers in the next section, 3.3, when we find quadratics. So 3.3 is going to be the quadratic functions. And so here's a bunch of definitions. I'll just leave it up there for you to see. Quadratics are these U-shaped graphs. They're parabolas. And so from the picture there, you see that we have some definitions, some things that are defined there. Now, one thing on there is you've got intercepts, which intercepts are things that we've seen before. So we've got places where it crosses the x-axis, that would be the x-intercepts. And this continues over here and it crosses the y-axis, and of course, that'd be the y-intercept. But we've got some other things on here as well. We've got this line here that's called the Axis of Symmetry. Now, this goes through what's referred to as the vertex. The vertex is either the lowest point or the highest point on the graph. If it opens up like this, the vertex is the lowest part of the graph, but it could also be flipped and being upside down U. If it's upside down U, then the vertex would be the highest point. This actually tells you over here whether the vertex is going to be the highest or lowest point It says it over here. So we have something that's called the vertex form, and we're in the vertex, we're labeling that as HK. So HK would be the coordinates of the vertex. If an equation is written specifically in this way, we can actually find the vertex directly from the equation. We can identify it directly from here. Now, if you notice, there's an A value that's in front of the vertex form. Now, that A value is going to tell you whether the vertex is the lowest point of the graph or the highest point of the graph. And it says it right here. Now, if the A is greater than 0, you're going to have a parabola that opens up like this drawing I have here. And as you see there, the vertex is down below. But if you have it like this, then the difference is that if it opens down like this picture, then you see here that if it opens down, the vertex would be the highest point of the graph. The vertex would be a maximum. So that's how you can tell whether it has a minimum or a maximum value, and that's just from the A value that you see here. But it has to be written in this form in order for you to be able to get the vertex directly from it. So we have an example here that we're going to work with that's already written in that form. By the way, one last thing I didn't talk about yet is the axis of symmetry. Now, the axis of symmetry always goes directly through the vertex. And again, if you have axis of symmetry, that's always a fold line. So that means that the graph is symmetric about this line that goes through the vertex. And then you can fold 1/2 over on top of itself. Okay, and so the axis of symmetry, the equation for it is this: x equals h. That's always the equation for the axis of symmetry. X equals h. It's x equals because it's a vertical line, and the h happens to be the x coordinate of the vertex, which, as you can see, the dotted line is always going to go through the vertex, and it will cross over at the x value of the vertex, which is h. So x equals h is how you're going to write that equation for it. Now, this equation right here is written in vertex form. We can compare it to the vertex form that's given up here. What you're going to do, if you want to find the vertex, the way this works is whatever the h is, it's always going to be the opposite sign of what you see inside the parentheses. The k value will be exactly the same sign as what you see on the outside. So right here, because I have a +3, I'm going to put -3 in there instead. Okay, so it's always opposite sign of what is in the parentheses. The reason why that is because since the vertex form has to always be written as x minus something, you can change a plus into a minus by doing x minus a -3. So that's actually the mathematical reason why it's -3. But the shortcut way would be just take the opposite sign of what's inside the parentheses. Then we're going to take the same sign as the number after the parentheses. So our vertex is going to be -3, 8. That's an actual point on the graph itself. Now, the axis of symmetry, I put that up here. The formula is x equals h. So for down here, I'm just going to put x equals, and I'm going to put the x value of the vertex, which is -3. So that automatically becomes now your axis of symmetry. You just put x equals, then you just put the x coordinate of the vertex. All right, now these other ones down here, I put x-intercept and y-intercept, and it says what to do in order to find each of these. So if you want x-intercept, you want to put a 0 in for y. So I want to do 0 equals -2 times x plus 3 squared, and then plus 8. Now I want to solve this equation, and we're going to use the techniques we learned in the section CR14 in order to get this. So this one, I want to isolate the part that has a square. Now I'm going to solve this by using the square root method that we talked about last time. Okay, so that means that you have to isolate the part that has a square in it. So I'm going to move that over to the other side, like that. And then I'm going to divide both sides by 2. X plus 3 squared equals 4. Now that this is isolated, what I'll do is take the square root of both sides. So I'll do square root of x plus 3 squared Remember that when you take the square root, you have to do the plus or minus. So we're going to do plus or minus square root of 4. That's going to turn into two separate equations. X plus 3 equals 2. X plus 3 equals negative 2. You get those two equations that come from this. If you subtract the 3 from both sides, you're going to get negative 1. So that's the first intercept. And then the other one, subtract 3, and we get negative 5 as the other one. So you get negative 1 and negative 5. If you wanted to write them as coordinates, it would be negative 1 comma 0 and negative 5 comma 0 as a coordinate. Okay, so that would be those. Now, as we have the graph up here, I'm actually going to plot all these at the same time. We're still going to find the y-intercept as well, but let's go ahead and graph what we have so far. Negative 3 and 8 would be up here. That is the vertex. We got negative 1 comma 0 and negative 5 comma 0. One thing that you're always going to notice when you do these kind of problems is the vertex, the x value of the vertex is always going to be halfway between the x-intercepts. The x-coordinate of the vertex is always halfway between the x-intercepts. And so that's will tell you if you did it right. If you got like this down here is 2 away, and if you got that one was way over here for some reason, then it's not symmetric, it's lopsided. And so it has to be the same distance away from the vertex. Again, it's talking about that fold line. So if the axis of symmetry is a fold line, then you should expect every point on one side of that dotted line will be the same distance on the other side of the dotted line. All right, now we have one more point that we want to find on here, and that's the y-intercept. That's where you put in a 0 for x. So I have y equals negative 2, 0 plus 3 squared plus 8. So we're just putting a 0 in for the x. And then we're going to simplify this. That is negative 2 times 3 squared plus 8. We want to follow our order of operations. Order of operations says that we have to square this first. So we get negative 2 times 9 plus 8. And if you simplify that, negative 18 plus 8, that's going to be negative 10. Okay, so negative 10 is what we get as a result here. Okay, from that original one. All right, so negative 10 is actually going to be all the way, it's off the graph, so it's down here somewhere. Okay, so now we're going to go ahead and we have enough information to draw the graph. It's going to, so down here somewhere, we'll have another point somewhere about right there. So that's going to come up here. The graph will go all the way up to this, and then it's going to fall and make that look a little bit better. It's going to come up here and go through there and keep on going down through the end down below here and connect with this point. So it kind of come down and go through there. Okay, so that would be what your graph looks like. It's upside down U shape like this. It's upside down because you've got a negative 2 right here. So the negative 2 there, negative sign flips it. And we see here that the vertex is actually the highest point that you have on the graph. Now, another thing it'll ask you for is on this question, I didn't ask it here, but some of the questions in the homework, they ask for the domain and the range. So let's do that on here as well, excuse me. So we'll do that in here. Now, domain is talking about the x values that the graph uses. If I take a look at this original equation, there's no restrictions on the original equation I had. There's no division by 0. There's no square roots of negative numbers. None of that happens. And so if none of that happens, your domain is always going to be negative infinity to positive infinity. So what that means is that since this graph keeps going down forever, the graph's going to get wider and wider. And it's going to use more and more x values. Uses more x values, so it's going to get wider and wider. That means it's going to use all the x values, negative infinity to positive infinity. However, for the range, we do have a restriction here because we see that the highest the graph is ever going to go is all the way up to 8. This goes up and then it goes down. So the range, it goes down forever. So it's going to go down to negative infinity, but that's going to go up to 8, and 8 is going to have a bracket on it because that point is actually included. So it's going to go from negative infinity all the way up to 8 and includes 8 because it's an actual point. It's a closed circle on your graph. The vertex does exist there. That's the highest it's ever going to go. So the range is the y values that the graph uses. So your domain, negative infinity to positive infinity, and your range is negative infinity to 8 with a bracket. So that's domain and range there. Okay, so another thing that happens is what happens now if I have a graph that's written out in standard form like this, ax squared plus bx plus c. From there, I can't tell what the vertex is from that point. Now, there is a process where you could change the standard form into the vertex form by doing complete the square. So we could do that and do the complete the square steps, but instead we have a formula that's going to be easier to use. If you have something that's written in this form, ax squared plus bx plus c, this formula will allow us to find the vertex of that. It's negative b over 2a, where the a, b, and c, they come from this formula there. If you want to find the y coordinate, we just put whatever x value we get, we just plug it back into the original one to get the y value. So let's do an example with that. We have 3x squared plus 6x. So for this, we have a, the b is 6, and the c is 1, although we don't use c here. We're only using a and b is all you need on this because of the formula. So x equals, we're going to use the negative b over 2a because we want to find the vertex. That's going to be negative 6 over 2 times a, or 2 times 3. So we get negative 6 over 6, which is going to give you negative 1. So the x value of the vertex is equal to negative 1. Next, we want to find the y value. To do that, you're just going to take our answer of negative 1 and plug it into the x's. So 3 times negative 1 squared plus 6 times negative 1 plus 1. We'll do that. And we're just going to simplify this to get the y value. This is 3 times 1 squared is 1, so we get 3 here minus 6 plus 1. And so if we simplify that, 3 minus 6 is negative 3 plus 1 is negative 2. So the vertex of this is going to be negative 1, negative 2. That's what you put down for the vertex. Okay, so you do negative b over 2a first to get the x coordinate. And if you want to get the y coordinate of the vertex, you put the negative 1, whatever x value you get, plug it back into the original equation for x, and that's going to give you the y value. A vertex is always a point on the graph itself, so that's why this, that's why you plug it back into the original equation. If you know the x value, then you can find the y value. All right, next one, it says find the vertex, and then it asks you to find the axis of symmetry. Okay, so here is the a, and this is the b. Our formula, again, is x equals negative b over 2a. All right, so negative b, that's negative times negative 5 over a, 2 times negative 2. Okay, so be careful with the double negative here. We have a negative in the formula, but you also have a negative in the b value. Negative negative is going to give you positive 5 over, and that's going to be negative 4. And it doesn't reduce, and so we get negative 5/4. So now if we want to find the y value, unfortunately we have to work with fractions here, but we can still do that easily enough. So we'll put in the fraction for each of these. So all the x's, we're going to put in negative 5/4. So now we're going to simplify all this. Now, -2, I'm going to write this as a fraction. So -2 can be written as -2/1. Now this, you square the top and square the bottom. So you get 25/4. I'm sorry, 25/16. Just look a little bit neater here. Yeah, 25/16 you get there. This is a plus, and you get 25/4. Yeah, +1 there. This first fraction we can reduce. Okay, so we can do the 2 and 16 reduce there. So we get y equals -25 -25/8. And we have 25/4, which I need to get common denominators. So the rest of this, I want to get common denominators with the last two fractions. So 8 is the common denominator that I want to make all those equal to. So this one I'm going to multiply the 25/4 by 2/2. And then the 1 over there, I'll multiply that by 8/8, or just write it as 8/8 like I have here. Now I have everything all in the same denominator. So I can now just add that all together. Okay, so I have 50 minus 25 is 25. 25 plus 8 is 33. So we're going to get 33/8 like that. So the vertex is going to be, look a little bit neater here. Vertex is going to be -5/4 and 33/8. Now it also asks you for the axis of symmetry. So axis of symmetry, you put x equals, and then you just put the x coordinate of the vertex. So on that, the axis of symmetry would be x equals -5/4. And we have our vertex is fractions, but that's okay. Sometimes happens, so it's fine. Next, it says, determine without graphing whether the quadratic function has a maximum value or a minimum value, and then find the value. Okay, well, first of all, you see that the a value right here, a value is -2, and your b value is 8. And so for that, since a is less than 0, the vertex will be a max. So the vertex is a maximum value. Okay, that's because if it's a max, it's going to be a U shape that opens down like that. So if it opens down, which it does here, because the a value is negative, then it does this. And so that's how we know the vertex is going to be a max. So now we have to find the vertex by using the -b/2a formula. So we have -b is -8/2 times a, 2 times -2. And we get -8, or actually the negatives cancel out here, well, because we get -8/-4, which is 2. So your x value is +2. So now we got to find the y value, and we just put the 2 for all the x's in the original equation like that. And so we get -8 here plus 16 plus 3. So putting that in there, we get -8 plus 16. So 16 minus 8 is 8. 8 plus 3 is 11. So the vertex is going to be 2, 11. And so that is going to be the your answer for that. Now the vertex itself, 2, 11, that would be the highest point that you have on the graph. And of course, you could confirm that if you have Desmos or a graphing calculator, you can certainly confirm that that's what it would be. So that's your answer. All right. Now, the next questions that we're going to do are going to be graphing questions. Okay, so the graphing questions, they'll have you graph that. And then again, even though it's, so this says domain and range here. I didn't put that on here, but it does tell you to define domain and range. So let's go ahead and we'll do that last once we have the graph. So let's do domain and range. We'll just do down below here. So we'll answer that later once we have a graph. That'll be easier to do at that point. So we'll do that later. All right. Now here's another one that is not written in the vertex form. So because they want us to find the vertex, we're going to use the negative b over 2a formula, negative b over 2a on this. And so for this one, the a is equal to 1 and your b is negative 6. So I have negative times negative 6 over 2 times 1 in front of the x squared. I get 6 over 2, which is equal to 3. So the x value is equal to 3 there. Okay. Now for the y value, we'll put 3 into all the x's. So I get 3 squared minus 6 times 3 plus 5. And now I just want to simplify that. So we get 9 minus 18 is negative 9. Negative 9 plus 5 is going to be negative 4. So the vertex is 3, negative 4. That's the vertex. The axis of symmetry, we can find that automatically because it's just going to be x equals the x coordinate of the vertex. And so your axis of symmetry would be 3, x equals 3. Next, we want to find intercepts. The x-intercept is where y equals 0. So I want to do 0 equals x squared minus 6x plus 5. Now this is something that can be factored. So this is why, again, we want to know the factoring techniques from the previous section. So I have x and x here. You're looking for two numbers that multiply to make 5 and add to be 6. It's going to be 1 and 5. Both of those have to be negative, though, in order for it to add up to negative 6. If you set both of those equal to 0, you're going to get 1 and 5. Let's graph what we have so far. We have 3. We'll plot these points. So 3 and then negative 4 would be right there. I have a 1. I have a 5 as my two x-intercepts. And we can see here that these points are the same distance away from here. If you wanted to put the axis of symmetry, well, that would be this dotted line running all the way through here. So the dotted line would be the fold line. Everything on one side is exactly the same distance as all the points on the other side. So the distance of 2 away here and 2 away right there. Now we have one more point we want to find before we graph it, and that's going to be the y-intercept. So for the y-intercept, you put a 0 in for x. So you have y equals 0 squared minus 6 times 0 plus 5. Y equals 0 minus 0, so you just get a 5. Okay, so 5 would be the y-intercept. And so then I can put that on the graph. 1, 2, 3, 4, 5. It's going to be right here. Now, if I wanted to, even though I found this point, if I wanted to, I could also put, since this is a distance of 3 away, we know that the distance on the other side would also be a distance of 3 away, so we can get this point also. Again, every point on one side is the same distance as every point on the other side of the dotted line. Now we have enough to make our sketch. Of course, you'll be using the graphing tool in My Open Math. There's parabola tools that are in there in this section for you to use, but here we're doing it by hand. Okay. Domain for all of these in this section, the domain for all the quadratics are always going to be negative infinity to positive infinity no matter what. That's because there's no restrictions on what x values you can use. There's no division by 0, no square roots of negative numbers. So therefore, any x value will work in the original equation that we have here. The range that has to do with the vertex. The lowest point we see on this graph is at -4. So that's going to be -4 we put with the bracket because that point's included. And that's going to go all the way to infinity. Okay, so we go from -4, the bracket, all the way up. Okay, there's no part of the graph that exists below 4, so that's below -4, so that's why we have -4 here for starting out for the range. The range is just the y values the graph uses. And we've answered now everything for that particular question. So let's move on to, we'll do a couple more graphing questions. The next one we're going to do is this right here, y equals x squared minus 5. All right, so this one, we're going to do the vertex. Now in this case, we really have y equals x squared plus 0x minus 5. That's what you can think of that as, because there's no middle term, so it's really a 0x. So if you want to use the vertex formula, negative b over 2a, you have negative times 0 all over 2 times 1, and we get a 0. So that's the x coordinate of the vertex is 0. Now we're going to find the y value by putting 0 back into the original one. So I'm going to get y equals -5. So the vertex would be 0, -5, which also just so happens to be your y-intercept as well, as we see that that dot right there is on the y-axis. So down here, I can just automatically put 0, -5 down there for the y-intercept. We already did that by putting a 0 in. So that's both a y-intercept and it's a vertex at the same time. Okay, so we have both, we have that. Now the axis of symmetry, you're just going to put x equals the x coordinate of the vertex. So I have x equals 0. That's the fold line. So in this case, the y-axis is the fold line in this case. We now want to find the intercepts. Okay, for the x-intercept, we already found the y-intercept. So this means we need to put a 0 in for y. So I have 0 equals x squared minus 5. Now to solve this, we're going to use the square root principle. We're going to add 5 to the other side, just like that. And then we're going to take the square root of both sides. When we take the square root of both sides, this side with the number gets the plus or minus. And then square root of x squared is just x. Okay, so square root of both sides will get this here. Now, if you put square root of 5 into your calculator, we can get a decimal version for that. So if you do that one, you're going to get about 2.2. Okay, so this here is 2.2 approximately. So on our graph here, I've got plus 2.2, which is about right here. I have negative 2.2, which is over right here. All right, so we get that. So that's going to be approximately where our graph is. Now that's the only points that we have, which is enough. We can go ahead and graph that with just those points. The graphing tool in MyOpenMath would allow you to graph that only with those points as well. Now, when you do these in MyOpenMath, you always have to click on the vertex first. So you'll click on the vertex and then click on either one of the x-intercepts. And that's going to be how you lock in your answer when you do these in MyOpenMath. Let's do domain and range on this one too. So domain, and we'll do the range. Domain, again, on all the ones in this section, domain is always negative infinity to positive infinity. The range is affected by whatever the vertex is. The lowest point in the graph is -5. So -5 is going to have a bracket, and that goes all the way up to infinity. Again, range is the y values that are used here. All right, get that. Let's do one more graphing question here. Now this up here, what I recommend first is go ahead and rewrite this as putting it in order from the highest to lowest power. If you don't do that, you run the risk of making a mistake of putting in the wrong values for A, B, A and B when you do the vertex formula. So make sure it's always rewritten like that with highest to lowest power. If they give you something that's in the wrong order, go ahead and put it in the order there. We want to use the vertex formula on this once again. So negative b over 2a we're going to use for this. Negative b, so we have negative times negative 4. And be careful what the double negatives you got on that. All over 2 times a, 2 times 1. And we get 4 over 2, which is equal to 2. So that's the x value of your vertex. To find the y value, we just put that back into this one here, 2 squared minus 4 times 2 plus 6. So we get 4 minus 8 plus 6. 4 minus 8 is negative 4 plus 6 is 2. So the vertex here is 2, 2. Okay, we have that. Axis of symmetry, you just put x equals the x coordinate of the vertex. In this case, x equals 2. We want to find the x-intercept by putting a 0 in for the y. So that would be 0 equals x squared minus 4x plus 6. Now, unfortunately, on this problem, we don't have something that can be factored. Numbers that multiply to make 6, that add to be negative 4, you're not going to find a pair of numbers that does that. So if it doesn't work that way, then you have to use the quadratic formula, because it's probably going to be a decimal answer when we do that. So quadratic formula, the b is negative 4, so I have negative times negative 4, plus minus the square root of b squared, negative 4 squared minus 4 times a is 1 and c is 6. All that over 2 times a, 2 times 1. Now we want to simplify this as much as possible. So we have x is equal to 4 plus or minus the square root. We have 16 minus 24. Okay, so now we notice what's happening here is we get an imaginary number inside because we don't get a positive. So we're still going to continue that, and we're still going to actually get our answer in terms of I, like we did with the last section. So let's keep on going with this. We're going to get 4 plus or minus the square root. All right, so we're going to do inside there. Again, no matter what this is, even though you notice that it's a negative number, we still want to actually simplify this down as much as possible here. So this will be negative 8 over 2. Let's keep on going. The square root of negative 8. 8 is the same thing as 4 times 2. So basically this is going to be the square root of 4 times the square root of 2 times the square root of negative 1 is what you can think of that as. Square root of 4 is a 2, and then the square root of negative 1 is your I, and then we just have a 2 left over. So we'll write it this way, 2i square root of 2, and then we're dividing all this by 2 in the bottom, so we can split this up 4 over 2 plus or minus 2i root 2 over 2, and that's going to give us our final answer of 2 plus or minus I square root of 2. Okay, so that's what we get by simplifying all that. So 2 plus or minus I over I squared root of 2. So we did find x-intercepts. However, you're actually not going to see these appear on our graph. We cannot plot those. Now, the reason why we can't plot that is because this is a real number axis. Okay, so we don't have an imaginary axis on this. So unfortunately, we're not able to graph that. So although we found x-intercepts there, they're imaginary. They're not going to appear on the graph itself. So far, we've got the point 2, 2, and we also have our axis of symmetry down here. Okay, so that's all we have so far. But we can find one more point. We can find the y-intercept, where you put a 0 in for x. So I have 0 squared minus 4 times 0 plus 6. So I get y equals 6 for the y-intercept. So 0, 6 is another one that I can put on here. That's going to be right here. What we know about the axis of symmetry is any point on the left side is going to be the same distance away on the right-hand side. So I can come up with this point as well. This is the y-intercept. It's the distance of 2 away from the axis of symmetry, but this point over here must also be a distance of 2 away from the axis of symmetry. So we're still able to get a graph, even though we only have 3 points. That's enough to determine what that would be. For the domain is negative infinity to positive infinity. And if you want the range is going to be from 2 is the lowest point. So let's actually do a bracket on that, 2. And that's going to go to infinity. Okay, so 2 is the lowest point. It goes up there to infinity. That's your range there. Again, bracket will always be there because that point is actually included on the graph itself. So as we see here, if you look at the graph does not cross the x-axis. And so whenever you have a quadratic equation that does not ever cross the x-axis, you're always going to end up with imaginary numbers as a result. So that's what happens. That's why you get imaginary solutions. That's when the graph that never crosses. Now, it's possible that the graph could cross at a decimal as well. So just because you're using quadratic formula doesn't necessarily mean that you're going to get an I in your answer. You might get like square root of 2 or square root of 7, something like that, where the graph crosses not at a whole number, but it crosses at a decimal. So that would happen too. But if the graph does not cross at all, then that's when you are going to get, for sure, you're going to get the I's as part of your answer, imaginary numbers. All right, so now the last sections that we have here, and I'm only going to do one problem before we go, and we'll do the rest of these next time. But we're going to be doing what's referred to as modeling with quadratic equations or quadratic functions. So I'll do one of these for you so you can see the basic idea, but all of these are going to be word problems that have the either maximum, minimum, or you might have largest, smallest, those kind of keywords you'll have in there. And so all those problems, if you have largest, smallest, maximum, minimum, you have to find the vertex in order to get the highest or lowest point on the graph. So again, that's why we talked about this earlier with the graphs. You do minimum or maximum values. So that's the key to doing these. Once you have the quadratic formula, you'll find the vertex to answer whatever it is they're asking you for. So here's the first one that we're going to start with. And this is the only one we'll do for today, and we'll do the rest of them next time. So it says, suppose the height of an object shot straight up is given by this. So this formula is provided for us already. It's a quadratic formula. H is measured in feet and T is measured in seconds. It says, find the maximum height that object reaches and then the time at which the object hits the ground. All right, so if I want to find the maximum height, that's that keyword. Maximum height means I want to find the vertex. So first what I want to do is I'm going to rearrange this and write it with highest to lowest power. So I'll start with that. Okay, so I have this. That way I can get the A and the B correct here. So A is going to be negative 16 because that comes in front of the x squared, or the t squared here. And the B comes in front of the non-squared variable there. So I have A and B. Now the formula that I'm going to use is, instead of x's, we have a t instead. So t is going to be equal to negative b over 2a. That's going to be negative 512 divided by 2 times negative 16. So I want to do, it's going to be negative 512, and that's divided by negative 32. Now, if you do this in your calculator, okay, I want to go ahead and make a point about this. If you put this in the calculator, it's negative 512. Now, when you put that in the calculator, make sure you put all this on the bottom in parentheses. You want to do 2 times negative 16, and you want to put it in your calculator like this. You want to make sure you put these parentheses in here because the most common mistake I see students making here is they'll just put it in the calculator as is. They'll put negative 512 slash 2 and then times negative 16. That's not going to get you the right answer. because the calculator is not doing that the way you want it to be done. These are two separate things. So you have to do the multiplication first before you do the division with order of operations. So you actually want to do this first. And so when you put it in the calculator, it's going to be done properly like that. So if you put this in the calculator correctly, what you're going to get with that after you divide is you're going to get 16. Okay, so 16, and that's going to be in seconds. Okay, now that's not the right answer because it's asking for what's the maximum height that's reached. 16 seconds just tells you how long it takes to go all the way up. Okay, so you want to know what the height actually is at 16 seconds, which means that we're going to put 16 seconds in for both of the t's. Okay, so I have this, I've got negative 16 times 16 squared and 512 times 16. Okay, so we want to put that into the calculator. And so we get, this is negative 4,096 we get for this first part. So this is negative 4096. And then if you have 512 times 16, we're going to get 8192. And then if you combine this together and subtract it, you're going to get, is your answer 4,096 we get. Okay, so 4,096 feet, that is the maximum height. That answers the first question. The second question says, find the time at which the object hits the ground. Now this you can do a couple different ways. Now one way you can do so that's the first question. The second part, you want to find when the object hits the ground. You could do it algebraically where you put in a 0. So 0 equals 512t minus 16t squared. So we'll put that in for this, and then you're going to factor each of those. A little bit neater here on that. 512t minus 16t squared. And then from here, you can pull out there's a 16t that's common in both of those. So we'll pull that out. And if you do that, you get a 32 minus t left over for that. And then if you set that equal to 0, you get 16t equals 0 and 32 minus t equals 0. This one, if you divide 16, you'll get a 0 there. This one, if you add t the other side, you'll get t equals 32 seconds. So of course, it's on the ground initially, but you want to find out when it lands on the ground later after the flight has occurred. So that's going to be 32 seconds is going to be your answer there. Now, if you think about it, you could have also done this one intuitively as well. If it takes 16 seconds to go all the way up to the top, that means it must take 16 seconds to fall. So you could have gotten the answer that way as well, just by doubling the 16, and you get 32 seconds. So either way, you'll get the answer of 32 seconds for that. So this is it. We're going to go ahead and stop at this point. We're not done with this section yet. We got a couple more word problems that we're going to do that's like the ones in the homework, but you should be able to get started with the homework and do most of it in there. And we'll just do a couple more of these word problems we'll do tomorrow, and then we'll continue on with that. So with that, I'll go ahead and I'll stop here. Does anybody have any questions before we end this meeting? All right, so no questions here. I'll go ahead and end this meeting. Enjoy the rest of your day. See you guys tomorrow.